Okay, this is the next selected question from the Google Slides from our Google Classroom in grade 12 and on ratio and proportion, and they just get a little more challenging as we go along. But maybe this isn't so bad. You just take it step by step. Okay, the first thing here, read this up here. It says DB is parallel to FC and CE is parallel to FD. So put that in, BD and CF, CE and FD. So now you're looking at the picture. If they haven't put it in, you put it in. Now it tells us that AG is half as big as GF. Now it's a little bit better to write it as, I think, just to put the GF down here. The ratio of AG to GF is 1 to 2. Well, that means now you can use, so if this is 1, this is 2, but we don't know how long it is, so we just call it 1x and 2x. And the reason this is true is because it was given up here. But let's write it in here. AG is x, and all the way from G to F is 2x. This makes up 2x. Well, what else did they tell you? That the diagonals of a parallelogram, that's the parallelogram GF. Oops, sorry about that. The parallelogram GCFD, that's a parallelogram to C, sets of parallel lines. They intersect at C. But what do we know about the diagonals of a parallelogram? They cut into each other into equal pieces. They bisect each other. So we could say that GF and HF, they both have to be x, because it's 2x all the way across. We just figured that out. And why? Because the diagonals of a parallelogram bisect. And there's your reason. And there's something else. Let's put them in there. We know that's x, GH is x, and HF is x. So it's 1 to 1 to 1 there. We've got that whole thing. Now they say figure out what GH and the ratio of GH to HF is. Well, if we put this in here, we've got it. It's 1 to 1. That's the answer, and it flows out of the other information that we did. What about AG to GH? Well, that's 1 to 1 too. It flows right out of this being all these three segments being equal. 1 to 1. There you go. Now the next question's a little bit trickier. It says, figure out the ratio of AB to BC. So go AB to BC. Well, that's a triangle. There's a triangle here, but we need to use the proportionality theorem. We know that BG here is parallel to CF, and it makes these sides proportional. These parallel lines make the sides proportional. Now, I would like to see here, I'm highlighting in blue the triangle that I'm looking at. In triangle ACF, there's BG that's parallel to CF, so we can say these sides are proportional. So we can say that AB over BC equals AG over GF. And that's what we're supposed to for AB over BC. And we know that's in a ratio of 1x to 2x. So there's your answer. Why? Because of the proportionality theorem and that BG is parallel to CF. And we just use the proportionality theorem. What about AE and ED? Well, it looks like the same thing on the other side of the triangle. We're going to make those ratios. AE goes with ED the way that AG goes with GF. And what triangle are we looking at? I highlighted it in green. It's right here. And GE is parallel to FD. The proportionality theorem and GE being parallel to FD, that's the reason we can say that AE and ED are in a ratio of 1x to 2x because of this other part of the other side of the triangle. The sides of the triangle are proportional because of the parallel line there. Well, that was a little bit trickier, but there you go. I hope that explains it.